In last video, we have seen a comparison between linear search and binary search. Now we implement the knowledge that we have learned before to solve this problem. Need pair of numbers from arrays whose sum is greater than n. Let's see what is the problem is. We have an array of 3, 4, 2, 6 and n is equal to 7. I have to find a pair of number in this array whose sum is greater than 7. 3 plus 4 is greater than 7? No, because condition is greater than and not greater than and equal to. 3 plus 2 is greater than 7? No. 3 plus 6? 9. 3 plus 6 greater than 7? Yes. 4 plus 2? No. 4 plus 6? Yes. 2 plus 6? Yes. So the solution of this problem is 3 pairs, 3, 6, 4, 6 and 2, 6. I have to give only the number of pairs. So the answer is 3. Now, let me see one more example of it. Here I have an array where 1, 3, 4, 5, 7, 8 are the numbers of the array. If you have seen this problem, here these numbers are not in a sequence. But here, these numbers are in a sequence. Okay, let's apply the same logic here. That I will have 1 plus 3. Need pair of numbers from this array whose sum is greater than n. Here let n is equal to 12. So 1 plus 3 greater than 12? No. 1 plus 4? No. 1 plus 5? No. 1 plus 7? No. 1 plus 8? No. So I have keep this one static and check for these numbers 3, 4, 5, 7, 8. 3, 4, 5, 7, 8. Greater than 12? No. Now I have moved pointer from 0 to 1 and keep it to 3. So 3 is constant here. And now I will check for 4, 5, 7, 8. 4, 5, 7, 8. Whichever is greater than 12, total sum? No. Now let me check for 4. 4 plus 5 greater than 12? No. 4 plus 7 greater than 12? No. 4 plus 8 is 12. It is not greater than. If someone says you greater than or equal to, then this pair will come, else not. 5 plus 7 greater than 12. 5 plus 8 greater than 12? Yes. Similarly, 7 plus 8. If someone says that it is greater than or equal to, there is only one greater than or equal to check present there, which we will check here in the code. Let's see an algorithm for it. Algorithm says I have a int result. This is initialize the pair of number as 0. Then I have for loop int I is equal to 0. Array dot length minus 1 I plus plus int j is equal to I plus 1. Instead of 0, start from I plus 1. Array dot length j plus plus. This is array dot length till last I am getting, and this is length minus 1. Let me check here. I started from 0 and it is going till 7. Check this side of number 1, 3, 4, 5, 7. These are I basically. Basically Z is I plus 1. Internal for loop will start from here, I plus 1. And it is going till end. So 8 is coming till end. So for I is equal to 0 and j is equal to I plus 1, I am running it 3, 4, 5, 7, 8. How many I are there? 1, 2, 3, 4 and 5 I. 1, 2, 3, 4 and 5 I. And j is started from here to here. Similarly, for when I moves to I plus 1, j will move from j is equal to I plus 1. So j will start from here and will go till end 4, 5, 7, 8. Similarly, for I will come here. So j will have 3, 4 and 5 index. That is, when it is 4, it will have 5, 7 and 8. For 5, it will have 7 and 8, and for 7, it has only 8. So now I will have sum of array I plus array j, which is greater than num. I will have result plus plus. Now if I will say greater than or equal to, that is, I need this pair and this pair also, then I will simply have greater than or equal to here. And this is the result. Now let me go back to the example. Here my sequence is in ordered form. And this input is not ordered. If this input is not ordered, this is only a best solution. But if I have input in ordered form, then something better than this I have. If input is in ordered form, I have remember of binary search. The array is sorted. Can I apply somewhere here? Let's see. If I will apply binary search here, then what would be the complexity here? It would be log n for binary search. Log n for binary search. Now I have find method. Basically, I will have again int result is equal to 0, initialize the sum of number equal to 0. Then I have for loop int I is equal to 0, I less than array dot length minus 1 I plus plus. This is the same for loop. But here I am calling find method. This is the find method of binary search, where I am passing the array here. I am passing starting element, that is start index, and I am passing the last index. And here I am passing the number that I need to search. Here I am not passing the num here. Here I am passing the num minus array I. What is this num minus array I? Let me go and check it back here. Basically, I have this n as a number here. Instead of checking 12 here, I am checking for 12 minus 1. I have 12, I will do minus 1, that is 11. And I am searching that 11 in this part. So instead of searching against each number, I am searching by a binary search. 12 minus 1. Then 12 minus 3, I will search in this part. Then 12 minus 4, I will search in this part. 12 minus 5, I will search in this part. 12 minus 7, I will search in this part. So each 12 minus 1, and I am searching a binary search here. So log n is the complexity. But for this part, again log n is the complexity. For this part, log n is the complexity. For this part, log n is the complexity. I have total n elements and log n is for each. So the total complexity is n log n. What is the total complexity? It is n log n. Let me go back here. This code will have a basically complexity of n square, and here log n is the complexity of binary search. And when I am put this log n in this for loop, so the total complexity would be n log n. Total complexity would be n log n. So this is the logic to find that. What is the logic of this find? This we have used it before. Let's see a demo around it. This is my first program where I have array 1, 3, 4, 5, 7, 8, and here I have calling sum of pairs, and it is my 2 for loops. I am just comparing the sum greater than number and result plus plus. Let me go and run this for you. I have 1, 3, 4, 5, 7, 8, and I have basically passing choosing for 10 here, and the answer is 6 2. Now let me go to the another program. In this program, I have class name implement bs1. I have class bs1. I have a find method. This is the find method of binary search, where I have the array here, I have the number here, I have the start and end. Another part, everything is same till here. Now I have array of which I have to pass the sum of the sequence, and this array is in a sequence mode. It is ordered form 1, 3, 4, 5, 7, 8. Now I have method sum of pairs, where I am initializing the sum of pairs at result 0, and I have for loop I is equal to 0, I array dot length minus 1, I plus plus. Now I am calling the find method, which will have sum minus array of I. Each time I will proceed here into the array, I equal to 0 to I array dot length minus 1, and I will have num, that is 12 minus 3, 12 minus 4, like this. Then I have starting index and the last index. I will get this n. Now After getting this n, I have while loop here, where I'm saying n is less than array dot length minus 1, have result plus plus and n plus plus. N plus plus is to check out this while loop, and result plus plus is to increment this result of it. Now you will say, Arun, while is equivalent to for loop, and I have for loop inside a for loop. That means n cross m. If it is n cross m, it would be n square. So why the solution is n log n? It should be n square log n. The answer is no. Let me explain why. What we are doing in while loop, I am checking whether n is less than array dot length minus 1. Yes. Then do result plus plus. What even I can do? How many times n is less than array dot length minus 1? If array dot length minus 1, let me come up here. Let's say n is 3 and array dot length is equal to 7. So I am doing result plus plus and n plus plus. So why I am doing this? I can even do this. Result is equal to result plus array dot length minus 1 minus n, and it's done. So I'm just doing the increment operator. I can just replace this by there. So in that case, it is simply a for. I'm not doing any processing here. I'm just incrementing it 5 times, 3 times, 2 times. That's what. I can replace it by this function. So the complexity of this is 1. Now I have for loop which is calling n times. The complexity of this for loop is n, and complexity of this find operation is log n. So n multiplied to log n will be the complexity of this complete program. I have while less than this. Now if n modulus 2, if this number which I am passing it here, this modulus 2 double equal to 0, return result, else result minus 1. There is one more thing. Why I have put it these two conditions? This is to handle whether number is basically that we are checking is even or odd. Because 5 divided by 2 is 2.5. And if I am keeping that value in integer, it is 2. 4 divided by 2 is again 2. So whether you have 4 or 5. So that's why I have to check if number is divisible by 2. Simply return result. Else return result minus 1. This is to handle the even or odd condition of num. That's much. And we are done with the problem. Now let me go and run it for you. Here I am passing this array 1, 3, 4, 5, 7, 8. And what is the sum of pair I am checking for? I am checking for sum 13. Let me go and run it for you. How many number of sums are there? Sum of pair is 1. This is the answer. Even I have checked this as a test case. That if this is the array and the sum is 9, how many pair of are there? 6. If sum is 10, how many pair are there? 6. If sum is 12, how many number of pairs are there? 2. And if sum is 13, how many number of pairs are there? Thanks for watching this.